All right, so we're looking at where a graph is increasing, decreasing, or constant. So before we even get to that part, we need to make sure we know what these words mean, because that will make a difference. So the word increasing, does anyone know what the word increase means? Going up. So increasing means it's going up. So what do you think decreasing means then? Going down. Anyone know what the word constant means? Just staying the same. Perfect. So the word increase means going up. The decrease means going down, and constant means it's going to stay the same. So meaning it's flat. So let's look at what that looks like on a graph. So the very top of your paper, you have this picture with this guy on the bottom of it, and we've got some pieces that are labeled. When you are doing increasing, decreasing, and constant, in red up here you always use parentheses, so we don't have to worry about brackets at all. So everything's parentheses on these problems. And one other thing that's really, really important is you read the graph from left to right. So if you will write what I have in red up there, always use parentheses. You don't even have to write all the words, just write, always use parentheses. Every problem today is going to be parentheses. So write down just in big letters, always use parentheses, no brackets, all parentheses. And also circle or star or something where it says read from left to right. Those two things are really important. Everything's parentheses, and you always read the graph from left to right. If you go the opposite direction, you'll get the opposite answer. So left to right always, just like when you read regular words on a page. So left to right. So looking at this graph, if you read left to right, if we were tracing, or if I was walking on this, let's say we were in the mountains and I was walking on the line, that was where I was going to walk. If I'm going up, it's increasing. If I'm flat, walking on flat ground, it's constant. If I'm going downhill, it's decreasing. So looking at this graph, you can see this piece right here is going up, so it is increasing. This piece right here is going up, so it is increasing. So anywhere left to right, if I'm tracing it, if it's going up, it's increasing. If it's flat, it is constant. And moving left to right, still, if I'm going down, it is decreasing. So just looking at the graph, I can tell you, I could trace which pieces were increasing, which pieces were decreasing, which pieces are constant. Now we have to be able to write in numbers the answer to that. So how can I translate the graph to numbers? That's what we're doing. Can we say in numbers, where is the graph increasing? Where is it constant? Where is it decreasing? When you're doing these, you always use the x-axis. We're always doing left and right. The domain and range, we had to do both left and right and up and down. These ones, you're only doing left and right. That's it. Which means everything is going to be on our x-axis. So only use numbers from the x-axis. That's another important thing. So far, you know, you read left to right. We're always going to use parentheses, and also write this down. Only use numbers from the x-axis. Do not use the numbers on the y-axis ever in this. Everything's always left to right. So we're drawing our lines left to right and finding the numbers on our x-axis. So let's do some examples. So number one. So looking at the graph, the first thing that you have to be able to do is, can you tell where it's increasing or decreasing? So we're just going to talk about that, and then I'll tell you how to put it into an answer form. So just watch up here for just a minute. So starting at that point right there, I'm going down first. So if I'm going down from left to right, this piece would be decreasing, right? Then starting there, it starts to increase to this spot. So that piece is increasing. Then I go back down, so it's decreasing again. So just watch for a second. And then it's increasing again. And then it's constant. So does that make sense? Just how to say, tell me what parts are increasing, decreasing, just by tracing the graph. So if it's going down, if I trace, so if I'm tracing it, starting at the left, if I trace it and my pencil's going down on my paper, it's called decreasing. So that piece, I went down, so it's decreasing, that I have in yellow or in pink. Then the next piece, I would have to go back up, so it's increasing. And then so on and so forth. So let me show you how to find your answer. So this first piece from here, if I trace it to this spot right here, that is decreasing. So I need to name that piece. When you're doing that, we're going left to right. So I am thinking of these lines on this graph. So it is decreasing in between those two lines. I'm going to figure out where does that line start and stop on the x-axis. So I'm looking at where these lines that I've drawn touch the x-axis. So it's out at 1, 2, 3, 4, 5. So it's decreasing first. So I'm going to go -5 and it stops decreasing at -3. And I always use parentheses every time. So the first one, this one is at -5. This is at -3. The next section right here that I have in blue, this piece is now increasing. So I'm going to say, where does it start and stop? I'm going to draw a line where it's stopping. And I know that it's starting at that same spot. So I'm increasing from -3 and it stops at -1. So that line's -1. So it's increasing from those spots. Okay, the next spot is decreasing again. So starting at that spot, going down, right there, it's decreasing. So here, this line at -1, and it decreases until you get to here. So it decreases from -1 to +1. And in between those, we're going to put this kind of like a U-shaped thing. Don't put a little tail on it. It's just like a smiley face, U-shape. That's called the union. So we're going to put this union in between any of them. So make sure you include that union symbol. The next piece of my graph, I'm increasing again. So from that point and then to up to here, I'm increasing. So it increases. So I'm going to put union from 1 and it stops increasing at 2. I'm always using the numbers on my x-axis every time. So I'm drawing, if I kept drawing them, it gets kind of crowded with all these lines, but you're just thinking up and down every time, where does that touch? Then from there, it's constant, it's flat. So starting at 2, it's constant, and it's constant clear till it gets to this spot here, which is at 5. Because if I draw that line, it goes through 5. That's how your answer is going to look. You're just drawing everywhere it's increasing, decreasing, and you're going to have separate pieces for each with a union in between them. Okay, let's try another one. Number 2 has less pieces to it, so it's a little bit maybe easier to see. So starting on the left, if I start at this point here and I trace it until it stops going up. So it's going up, which means I'm increasing. So that piece right there is increasing because it's going up. So I'm going to name that piece. It starts increasing here. It stops increasing here. Those are the numbers I'm looking at. So if I count, I have 1, 2, 3, 4. So this line's at 4, -4, and this line's at -2. So it increases from -4 to -2. Then from that same spot, it starts to decrease down to here. So this is where it starts decreasing. This is where it stops decreasing. And that second line's at -1. So it goes from -2 to -1. And that's it. The graph's done. So do I have any flat pieces in my graph? No. So there is no constant, or you can just write none for constant. There's no constant. Don't write 0, just write none because there is not one. All right, let's try 3. So starting at the left, we're going to trace the graph. So first thing, we're going to trace the graph. It's got an arrow. You got to keep that arrow in mind, and it goes like this, and it stops right here. So on the left, does it have a stopping point on the left? So because it doesn't have a stopping point, it's decreasing starting at -infinity because it goes forever. It decreases starting forever to the left. It stops decreasing right here. That's where it stops decreasing. So at +1. So it goes from -infinity, stops at +1 where I have that line drawn. But then it starts at that same spot. It starts to increase. So starting at the same number, so starting at 1, it's increasing. And it increases and it doesn't ever stop increasing. It just goes forever. So it increases clear to infinity. and it is never constant, never flat. So I'm just going to write none for the constant. All right, so try another one, number 4. So tracing my graph, it's first increasing, then it turns and it goes to decreasing. So increasing first, then it goes down to decreasing. So increasing, this line right here is increasing and it stops increasing at the very top of that mountain, but it does have an arrow at that end. So it starts increasing clear at the left, all the way to the left. So it starts to increase at negative infinity. It stops at the very top of that graph, the very top of the hill looking thing. So that line I have drawn, that's where it's stopping, which is at -2. And then at that point, it starts to decrease. So I'm going to have from -2, and it decreases forever. It never stops decreasing. So it keeps going forever and ever and ever. So I'm going to have infinity for the ending part. It's never flat. So I'm going to have none for constant. You should be able to tell pretty quick if there's any constants. So you can tell that there's not going to be a constant on some of these pretty quickly. So number 5. So first looking at number 5, is there any flat pieces, any constant pieces? So we know there's not going to be any constants. You could just write none right on there to right from the beginning, because you can tell there's not going to be anything constant, no flat pieces. But we do have a few increasing, decreasing pieces. So we're going to have different parts here. So let's start on the left, and it's increasing first from here till you get to the very top. Right there is where it stops increasing. But the arrow's on the other end. So it increases from forever to the left. So it's increasing from negative infinity. And it increases until it gets to that top number. But remember, we're always using the X number. So your line goes up and down. So that passes through -3. And then it starts to decrease at that same point and decreases till the bottom of that little hill there. So it's starting at this -3 and it's stopping at this point, which is at 1. So that line's at -3, that line's at 1. So it decreases from -3 to -1, not +1. And remember, all these should have parentheses. We don't have any brackets. Then we start to increase again. So starting at the same point, it increases. So we're going to put a union. And it starts at -1. And it goes to the top of the hill, which is at +1. So it goes from -1 to +1 for my increasing. Then it starts to decrease again. So I'm going to put a union, starts decreasing at that number, and then it keeps decreasing forever and ever and ever because it has an arrow. So it starts at +1 and it decreases forever and ever to the right side. So it goes to infinity. And you're thinking right, that's why it's positive infinity. You're always thinking right and left. It is pointing down, but we don't care that it's pointing down. We just care that it's going to the right. Right is positive, left is negative. All right, number 6. This one's kind of a tricky one. If I trace this graph, first of all, is it ever constant? Does it ever completely flatten out? So I know there's no constant, so I'm going to write none there. Does it ever go up? Like if I trace this graph, does it ever go up? It doesn't. So this graph is going down and it kind of flattens a little bit, but it's still going down. The whole time, it's just slowly going down in the middle, but it's always decreasing. So it is going down and then it kind of flattens a little, but it's still going down. The whole graph is going down from the start to the end. And the left side, it has an arrow, so it goes forever to the left. So it's decreasing from negative infinity. And it continues to decrease all the way across your graph, and it has an arrow on the right side, and it decreases forever to the right, and it is never increasing. So I just have decreasing on the entire graph from negative infinity to positive infinity. The entire graph is decreasing. Okay, so number 7. What do you think here? What do we not have? Which ones are going to be none? Increasing and decreasing, right? We don't have anything going up. So increasing is none. We don't have anything going down, but we do have a constant, right? And you have arrows at the end of those. If you can see, can you tell there are arrows on your paper? So those are arrows at the end. So if this is an arrow going forever right, forever left, it is constant forever to the left side, forever to the right side. It's constant all the way across. So it's constant from negative infinity to infinity. And it's never increasing, never decreasing. Okay, 8. So first piece is going up, tracing it. We're going up, so increasing first. So this line here, we're increasing. And it has an arrow, so it starts clear at the left, which is at negative infinity. And then it increases clear till we get to the top of that line, which is at -1 if we draw our line going up and down. So it stops increasing at -1. Then it's flat. So we just have to say where it starts and stops. So it's flat starting at -1, so constant. And it goes flat until we get to this next line, which is +1, the next spot. Then it starts to increase again. Be careful, it's not decreasing, it's increasing again. So our increase is going to have a U shape, the union, and it increases starting at 1, and it increases forever and ever, so it goes to infinity. And it never is decreasing, so that's going to be none. Okay, number 9. This one's kind of a tricky one. So first of all, the easy part is it ever increasing or decreasing? No, it's not going up, it's not going down. So increasing is going to be none, decreasing is going to be none. That part's not too crazy. The constant, everything's constant. If I can take the graph, if I were to line them up, like move them on top of each other so they're in a line, if I were to shift this graph down, it would be right here, right? If I were to just shift it down, and I'm kind of imagining that that's happening because if I do that, there are no gaps, right? There's no like spaces in between those lines. So if that's the case, it starts being constant here and it stops being constant here because there are no gaps in it. Now, if that top line, if this was not there at all, then I would have to have 2 parts to my answer because there's a constant piece, then there's a hole, then there's a constant piece. But if the constant pieces all get put together, if there's no hole, then you just do one answer. So we're going to have one answer from -4 to 5 because it's constant. Even though it moves up, it's still constant, no matter if it's higher or lower or right in line with it. But like I said, if this piece wasn't there, then I would have to have a part of my answer for the first chunk and another answer for the second chunk. Do you see? Does that make sense? Okay, so let's do 10. Okay, so first piece is constant. It's got an arrow on the left side, so it's constant from negative infinity. And it stops right here. Whoops, draw that kind of weird. Stops right here at -1. So that's where it's constant. And starting at -1, so it's jumped down, but it's still on that same line. It's starting to decrease. It's got just this teeny piece that's decreasing right here. So it decreases starting at -1, and it stops decreasing at 0. So remember, we're drawing the line going this way. So that's at 0. Then it increases starting at that same number. So it's increasing at 0, and it increases forever and ever and ever. So it goes to infinity. All right, last 2. Okay, 11. So what is this one not doing? Which things are we going to write none on? Decreasing and constant. Good. It's never going to decrease. It's never going to be constant, but it is increasing the entire time. So it's here and it keeps increasing. So it starts to increase at that spot, the left spot, which is at 0. Remember, we're only getting numbers off the x-axis. Don't use your y-axis at all. And it goes forever to the right. So it's increasing from 0 to infinity. All right, one more, last one. We have a couple different things happening on the last one. What is it not doing though, for sure? It's not constant. So we're going to say none for constant. So we know that right off. So it's increasing, then it's decreasing, then it's increasing. So let's start with the increasing. So this first piece right here is increasing. It's going up, starting at negative infinity because it goes forever because of the arrow. It stops right here at -2. Then we start to decrease, starting at the same spot. So it's decreasing from -2, and it goes down to the very bottom of that hill, which is right at this spot, which is at +1. So this line right here is at +1, and that's where it stopped to decrease. And then we start to increase, starting at that same line. So we're going to put a union, starts at 1, and it increases forever and ever and ever and ever. And that's it. Okay, so one really important thing that is probably the most common mistake I see, make sure you only use numbers on the x-axis. Do not use the y-axis at all. Just pretend like it's not even there. You're only using the numbers off the x-axis for this entire assignment.